Hello everybody, once again making another video for y'all for a little bit of study material. I know, obviously, I mentioned it in the other video, but because Friday, May 15th was my last day, I won't be there for you guys to actually take the test, so I might as well drop another video, help you guys out as much as I can before I'm, I don't know, going to the ether. So, the other video I made was about like the word problems that we've been working with and you'll probably see on the test. But this one's more just like the raw math of it, right? So like obviously we have two rational functions that are being added equals x over 9, right? I got x squared minus 6x plus 6x over x minus 12, yada yada yada. Anytime I'm adding rational functions, obviously these two functions have the same denominator, right? They both have x minus 12. But I need all three functions, all three parts, to have the same denominator, right? Like this is x minus 12, this is x minus 12, but this is a 9, right? In order to get the same denominator, I can't just add or subtract. You can't do anything to the denominator of a rational unless you multiply or divide. So if I want this x over 9 to have an x minus 12, I have to multiply it by x minus 12. But it's not just to the bottom of the fraction. I need to multiply it to the top and the bottom. The reason for that is that if we multiply the same thing to the top and the bottom of a fraction, it doesn't change the value of that fraction. While it does change how it looks, technically, x minus 12 divided by x minus 12, that's the same as multiplying by 1. So it doesn't actually change anything. If you don't understand that, that's fine. If you just want to understand what we have to do, then let's do it. So I see that we got 9 times x minus 12. So now they all have an x minus 12. But now these two functions don't have a 9. So I got to multiply these by 9. Notice how I'm writing parentheses around these things, because I need to make sure that I multiply the entire denominator and the entire numerator by this 9. Otherwise, it's not going to work out the way that we need it to. Because when I start this simplification, right, 9 times x squared minus 6x would be wrong, right? I'm not just multiplying 9 times x squared. I'm distributing this 9. So it's 9 times x squared minus 9 times 6x. Well, 9 times 6... Oh, why can't I do that in my head? It's 45? 54. It's 54x. And that's over this denominator. But if you guys remember, we see that we have the same denominator in everything, right? I have 9 times x minus 12, 9 times x minus 12, 9 times x minus 12. Once I have the same denominator in all of my fractions, well, that's big. Once I have the same denominator, I can straight up just get rid of it, right? Like, I will just take the numerator and focus on that, because the denominator is the same for all the functions. So I have 9 times x squared minus 54x, and then this gives me plus 54x, because 9 times 6 is 54. And then that's still equal to what's on the right, which I've got x times x and x times negative 12. So I got x times x is x squared minus 12 times x. I get minus 12x. So now I've got this problem where I gotta get x by itself. But I've got x squareds in here too, so I can't just get x equals a number like I could in that fidget spinner problem that I talked about in the other video. So first thing I want to do, I want to get any like terms added, right? Like I see I have a negative 54x and a positive 54x. Negative 54 plus 54, that's just 0. So those cancel each other out. So I've got 9x squared equals x squared minus 12x. So that's nice. A lot less to worry about. But literally any time we have an x squared in like this part of our like process where we're trying to find x, if we have x squared, I know I'm gonna have to do a box eventually. So if I'm gonna do a box, I need everything to equal 0. I can't do the box method unless I have like something x squared plus something equals 0. So I'm gonna move everything over. Whether I move the 9x squared over here and subtract 9x squared, or I subtract both of these things to the left, you're going to get the same answer. I just like working with positive numbers. So I'm going to move the smaller value, x squared, over. So I get 9 minus 1 is 8x squared equals negative 12x. I'm going to add that 12x on both sides. Ooh, geez. Plus 12x, so I get 8x squared plus 12x equals 0. I know my 8 and my 2 there look pretty bad, but don't worry about it. So I got 8x squared plus 12x equals 0. Now I can do my box. So I've got 8x squared in this box, geez, and 12x in this box. So I know it might be a little tricky when it comes to these types of boxes. We haven't worked with them too much lately, but it's still just seeing what can multiply, right? Like technically I could have like a 4x and an x multiply. It's actually, okay, well, that was a bad example because that's exactly what I wanted. But like, I'm looking at 8x squared and 12x. I know that I want to pull out as much as I can. Like, I could say that 2 times 4x squared plus 6x, and like that is true, but that doesn't really help me find zeros. Because that doesn't factor it by that much. So, when I see that I have an x in this one and an x in this one, granted this is x squared, both of these have an x, so I can pull out an x, right? Like, x times 8x equals 8x squared. X times 6 equals x times, or 12x, right? So technically I could have parentheses x and parentheses 8x plus 6. It'll get you the same answer if you did 8x squared, 12x. If I pulled out a 4x, which I can do because 4x times 2x gives me 8x squared, and 4x times 3 gives me 12x, both of these are going to get me the same x values. I was getting ahead of myself. This is an 8x plus 6. It's 8x plus 12. So 8x plus 12 times x, x times 8x is 8x squared. X times 12 is 12x. So if I were to do that math and find what x is, I get like 8x plus 12 equals 0, minus 12 on both sides. 8x equals negative 12, divide by 8, divide by 8. I get x equals negative 12 over 8, which, if you put in the calculator, that is negative 1.5. 1.5. But then if I do 2x plus 3 equals 0, subtract 3 on both sides, get 2x equals negative 3, divide by 2, I get x equals negative 3 over 2, which is also negative 1.5. So, no matter how you really factor this, as long as you realize that there's a x in both of them, you will get the same answer. It just works out that way for this problem, but make sure, if you can, try to pull out as much as you can from both terms, right? This 4x times 2x plus 3 is the most simplified you could have as an answer, or as a factor. So, whenever we're asked a problem where we have to solve this set of rational functions or solve for x. Or anytime I ask you to solve for something, you're looking for what x is. So in this case, x was -1/2, but I didn't set this x or this 4x equal to 0 yet. Like, if I do 4x equals 0, and I divide both sides by 4 to get x by itself, I get x equals 0 over 4. If I get x equals 0 over 4, that's just the same thing as 0, right? If I set this x equal to 0, I just get x equals 0, right? So in this problem, the answer is that x equals -1.5 and x equals 0 are both solutions to this equation. What if I plugged -1.5 in to all of this purple function, like before I multiplied, before I multiplied or after I multiplied, either way, if I plug x equals -1.5 in, or if I plug x equals 0 in, this sum is going to equal either -1.5 over 9 or 0 over 9. So sometimes when you end up, like, there's a few scenarios, right? Like, I do want to talk a bit about what you might encounter, because you won't always have an easy solution, I guess you could say. Like, you might have, like, if I have some function, like, I don't know, 1x plus 2 over 3 plus 5 over 6, x equals, I don't know, 1 over 2, right? Like, I have to multiply this 3 by 2x to make sure that it has the same denominator here, and multiply this denominator by 3x, right? Like, typically I'm going to have to multiply multiple things. And then, like, I know I'm kind of just rambling. I don't know if this will make sense to you guys. But, like, if I'm at my solution step, like here, let me scroll up so you can kind of see it some more. I'm at this solution step, and instead of getting, like, 8x squared minus 12x, where they both have an x in them, if I had gotten 8x squared minus 12, that's going to end up being our full 2 by 2 box, because I have a number and an x squared. But if I have x's in both of them, it's that 2 by 1 box. So you might encounter one, you might encounter the other, you might encounter both. I have no idea. But, of course, don't just use me as your only resource. There are answer keys on Schoology. Go watch Khan Academy videos if you have to. Go do your IXL. Do your homework. So, whatever. Well, again, to those who do watch these videos, I really appreciate you putting in the time and the effort. I hope that you guys do well in this test, and I hope you guys have a wonderful rest of your year. Obviously, I can't see you finish it up. Who knows? Maybe I'll make it in to say goodbye one last time towards, like, the end of the school year. I think that could be cool, but I don't know. I'm sure all of you will turn out to be wonderful people, very studious individuals. I learned a lot from being in this classroom, and I really appreciated the opportunity to work with you guys, learn from you guys, and obviously help you guys. I never wanted to fail any of my classes in high school, and having a student teacher, I think I had one in middle school, and honestly, big reason I actually showed up to class. He made me, actually care about, what was it, 7th grade science. About all I remember is that the mitochondria is the powerhouse of the cell. Real important information. But, yeah. Good luck with everything, guys.